All right, so for all of the questions on the front page, this is the position function that we were using. So they all kind of went together. And times are positive, so it goes from 0 onwards. And so what number 5 is asking for is the distance traveled in the first 3 seconds. I'm gonna need to go back and do number 4 before I can do number 5. So let me just go back a second. Number 4 is asking, when does the particle change direction? So in order to change direction, it has to stop. And so that would be velocity equals 0. So we're going to find the velocity, set it equal to 0. So this derivative would be 3t squared minus 3. And so we're going to add 3 and divide by 3 and then square root. Now normally you put plus and minus, but we don't do negative time. So just time 1 second. And so I'm going to make a sign chart for my velocity and put 1 on there, and we're going to pick numbers in each section to test and see what the sign is. So I'm going to try 1/2. If I plug 1/2 into the velocity, 1/2 squared would be 1/4, times 3 would be 3/4, and then minus 3 is going to give us a negative result. And if I plug in a number bigger than 1, like 2, 2 squared is 4, times 3 is 12, minus 3 is 9, so that's a positive result. So the particle goes to the left and then goes to the right. So we had a change in direction at 1. And so what 5 is asking for is the total distance traveled in the first 3 seconds. So I'm going to make a chart for position. And so I need 0 and 3 if we're going to do the first 3 seconds. And then I also need when the particle stopped. So that is going to be 1. And so we're going to plug all of those into position. So if we plug in 0, we're going to get 0. If we plug in 1 minus 3 will give us -2. And then if we plug in 3, we're going to get 3 cubed, which is 27, minus 9, which would be 18. And so just to get a visual of what that's going to look like, we're going to start at 0. And then go to -2, and then up to +18. So we're going to add up those motions. So from 0 to -2 is 2, and then from -2 up to 18 would be a distance of 20, and so your total is 22 feet. All right, and then I know someone typed something else. Let me go back through the chat here. Number 9. All right, so let's look at number 9. All right, so this is the position function. And number 9, again, asking for the total distance. So actually, I'm going to have to do number 8 first. So it's the same thing we went through with 4 and 5 here. So number 8 is asking when the particle is at rest, that's going to be velocity equals 0. So this derivative is 3t squared minus 18t plus 24. And we're going to divide through by 3. And then it is going to factor. So that will split t minus 2 and t minus 4. And so we get time 2 seconds and time 4 seconds. So that was number 8. Number 9 is asking for the total distance in the first 5 seconds. So again, I'm going to make a chart for position. If we want the first 5 seconds, I need 0 and 5, and then I also need the 2 times that the particle stopped, which we just found are 2 and 4. And so those are going to get plugged into this original position equation. So if you plug in 0, you're going to get 9. If you plug in 2, and I'm just going to tell you these, you can use your calculator to plug these in. If you plug in 2 for all those times, you're going to get 29. If you plug in 4, you're going to get 25. And if you plug in 5, you're going to get 29. So to just have a visual of this, we're going to start at 9. And then it goes up to 29. And then back down to 25. And then back up to 29 again. And so we're going to add up all of that motion. So to go from 9 to 29 is a distance of 20 feet. From 29 down to 25 would be 4 feet. And then from 25 back up to 29 would be another 4 feet. So that is going to be 28 feet. All right, and then someone said 11B. Need a new piece of paper here. Hold on a second. And I have a feeling I'm going to have to do A in order to get to B. Yes, so I'll do 11A and B. So letter A is when is the particle at rest? So again, that's velocity equals 0. So this derivative is 3t squared minus 6t minus 9. And I'm going to divide through by 3, so that'll give me t squared minus 2t minus 3. And then that is going to factor into t plus 1, t minus 3. And so we don't get a result from this one. I had some people write t equals -1 seconds. We can't do negative time. So you're only going to get the result from this one. That would be times 3 seconds. So just remember, we can't do negative time. And so that is the only answer we get from that one. So for 11B, we're being asked, is the particle speeding up or slowing down at time 2? Oh, you know what? I guess I didn't need part A for that. Whoops. Oh, well, you got part A done for you as well. Speeding up or slowing down at time 2. So we're going to get the velocity at 2 and the acceleration at 2 and compare their signs. So actually, I don't need the actual value, just whether it's positive or negative. So if we plug 2 into velocity, 2 plus 1 would be positive, 2 minus 3 would be negative. So a positive times a negative is negative. So velocity is negative. I haven't gotten the acceleration function yet, so let me go back and find that. That will be the derivative of velocity. So this derivative would be 6t minus 6. And if I plug 2 into that, I'm going to get a positive result. And so velocity is negative, acceleration is positive. So we're going to say the particle is slowing down at time 2 seconds because V of 2 and A of 2 are opposite signs. And I just want to mention about writing out these justifications, because it seems like I'm being super picky with them, but I have to be that way because that's how they are on the AP exam. If you said they instead of velocity and acceleration, they don't take pronouns, so they won't take they or it or them. Like, you have to say velocity and acceleration. You can't just say the signs. Like, you have to say velocity and acceleration. You have to mention those. Also, you have to say opposite signs. If you just say are opposite, they won't take it because they aren't opposite functions. Their signs at that point are opposite. So you have to say opposite signs. Sounds like I'm being super picky, but that's because the graders are too for the AP exam. So just make sure you write it exactly like I've shown you. Don't leave anything out, just to make sure you get full credit for it. All right, and then maybe do you guys want to pick one more? Okay, I am hearing nothing there, so I am going to go ahead and stop the recording.